Okay, hi everybody. My name is Rebecca, for those that don't know me or haven't met me. And today I'm going to be speaking about tips for building custom views on Android with Canvas APIs. That's quite a long title, and it should probably just be shortened to Canvas APIs on Android. There we go, can you hear me now? Okay, so the reason why I'm going to give this talk to you is because for the past year or so, I've been working heavily with the Canvas APIs at the company that I work for. And there are some things that I've learned along the way that I wanted to share with everyone today. So that's me, I'm Rebecca, and I'm an Android developer at a company called Over. And we're basically a graphic design tool for mobile. So you can go check out the app on the store, and I work primarily on the Android side. And if you want to find me on Twitter, you can find me at Regaroo, if you want to ask me questions or too shy to introduce yourself here today. So today we're going to be talking a little bit about custom views and getting your hands dirty with working with Android custom views. So before I get into that, I wanted to gauge from the audience who has written a custom view on Android. A few hands, shy hands. I also feel like that because if someone asks me, I'm like, custom views. I'm not so sure I know everything about them. And I still don't think I do know everything about them. But today I'm going to be sharing what I do know. So if you ask me a question and I don't know, it's because I don't know everything about them, because there's so much to know about them. Okay, so let's talk a little bit about what a custom view is in Android. And before we dive into like the internals of working with a canvas and that kind of thing. So a custom view on Android is basically a UI component that is not part of your stock standard UI controls. So things such as your edit text or your text views or stuff like that, that's part of your standard control system built in with Android. Whereas a custom view is something that maybe isn't built into the system and something that you want to have that's a little bit different from what you have currently. And when do you normally use a custom view? Well, it's typically when the standard framework, the Android framework, doesn't have what you are envisioning for your app or what your designers have sent to you to build. Has that happened to you before? You get this custom component and you're like, this doesn't look like anything in the material design guidelines. It happens quite often because there are quite a few that aren't in the material design guidelines. So it can also be, a custom view can also be when you want a grouping of views and for easier use or reuse within your app across different screens or different areas. So when we talk about custom views, there's kind of two different thoughts around them. And the first one is what we call a compound view. And this is basically a group of views, so standard Android views. And you basically, to create one, like in this example, these 4 buttons over here at the top are just normal Android buttons, right? They're image buttons, but there's nothing fancy about them. But this component, or these 4 views, we could maybe reuse this in a different portion of our app. Maybe we wanted to have this exact same component with 4 buttons on every screen or something like that. So we could create what we call a compound view, which contains these 4 buttons in it. And all we need to do for that is extend some kind of view group, so something like a linear layout or a constraint layout. And then you can override 1 or 2 things if you want. And basically, you can put in your custom view, or not your custom views, your normal Android views in a normal layout and inflate it in this compound view. And I'd say doing things this way is like the sort of intermediate level way of building custom views, because you're essentially leveraging what the framework already has, but you're building on top of that because you're like packaging it in your own sort of view for people to use. So how do you make a custom view or compound view in this case? And this is a small example, but basically this compound view extends, This compound view extends linear layout, and that's a view group by default. And then what we do is we inflate a layout for this view. And that layout that we are inflating can contain our 4 image buttons that we're going to inflate with it. And now this compound view, we can put in any different like fragments or activity and use it and get all the functionality that we've defined inside here. We can add listeners or gestures or stuff if we wanted to in here as well. Okay, So that's compound views, but we're not going to go too much into what a compound view is. I'm going to talk more today about fully custom components, as what I like to call them. But basically, these are ones that you are drawing on the screen yourself. And you are manually drawing things, so you're saying draw a rectangle at this point, draw a circle at this point, draw a bitmap at this point, and that kind of thing. And this, I would say, is like difficulty level of pro difficulty, because it gets a lot more complicated. You have to work with a canvas. You have to maybe even handle your own gestures or touch events, and that can get quite complicated. As we know, the Android system already handles a lot of that for you. So this is a lot more difficult to implement, and I think this is a video. Yes. So this is an example of one of the custom components that I've built. It's basically a color picker. So you have this on screen on our little over editor, and you can drag this around and pick a color from the image that you're working on. And this was all written with a custom component and with Canvas and all that kind of thing. So we'll dive a little bit into some of how that works in later slides. Okay, so to get started with a custom component, we would generally create a class. I've been very original and called it custom view, but obviously you want to give it a name that's more meaningful, like color dropper view or whatever you're creating. And then we extend from view, and this will then create just a standard Android view with no extra frills or fuss, but there's nothing to it, right? All you get is a canvas, and that's like what we're going to be working with. So in order to start drawing and getting something onto a screen for people to see, you would start writing and drawing things in this onDraw method that we have, that we can override from a view. And here you will see you get a canvas object that comes back when we call, or when onDraw is called. And this canvas object is what we're going to start using and start working with to get something custom on our screen. Okay, so we got a canvas object, but what exactly is a canvas? So a canvas is basically just a blank space for you to draw onto. And I kind of like to think of it like people have the saying of a blank canvas, right? And that's exactly what this is. It's a blank space for you to draw onto. A little bit more prescriptive, because when you have a blank canvas like this, you can draw with any medium, you can do anything your heart desires, whereas an Android canvas, you've got to obviously program it and, you know, call methods that maybe aren't as easy to use as just drawing on a canvas. Okay, but this canvas class is actually not created by the Android system, right? So this canvas class is based on top of another class which is called skCanvas, or known from the library of Skier. Okay, anyone heard of Skier? Yay, one person in the back and my colleague. So basically, Skier is an open source graphics engine that Android has packaged with the operating system, and they've built on top of it and provided a bunch of really nice to use, easy to use functions on top of Skier, so that you don't have to like work with Skier itself. But the thing is, with Skier, most other platforms, or a lot of platforms, are using Skier under the hood. So if you're doing something like web development with a canvas, you get a canvas in web, you get a canvas concept on iOS, but most of those concepts are similar, very, very similar in how they work. So once you understand how a canvas works on Android, that knowledge can be ported or like adjusted in just for the context of where you're working. So if you're working on web or iOS, they're very, very similar. Okay. So let's talk a little bit about Canvas's coordinate system. So it's a little bit weird in how it works, but basically you have I'm really bad with left and right, so I'm totally going to get this wrong. But over here, you have the starting point is 0, 0, and it goes towards that way is the x-axis, and down is the y-axis. I'm not saying left or right because I'm totally going to screw it up. Anyway, so we have downwards is our y-axis going positive, and the x-axis going that way is positive. So if you go the other way, it's both negative if you go up or to the side. So the top left point, I should have just used my slides. The top left point is the starting point of your canvas, and that is obviously the point of 0, 0. And then all elements that you use are placed relative, all draw calls that we do are placed relative to this 0 point. So if you offset a call by a certain amount, it's offset from that 0 point. So in this example, you can see the XY offset here will move the rect down and to the right. Call me out if I'm wrong. Okay. And one thing to note about the canvas is that when you're working with it, you're using pixel values with it. So we're used to in Android working with DP, but when you're drawing on screen with canvas, you're using pixels. So you need to translate between those two. And any new canvas commands that you draw are drawn over previously drawn items. So if you draw a circle and then you say draw a rect at the same point, your rect will overlay on top of the circle that you've drawn. Okay, which is a little bit different from like linear layouts and stuff like that. Okay, so we know what a canvas is and like kind of the coordinate system and how that works, but how do I actually go about using this canvas object? So you need to do 4 things, or you need 4 things in order to draw something with a canvas. First, you need a bitmap to hold the pixels that will draw on screen for the user to see. And then you need a canvas, which is that canvas object that we've got in that onDraw call. And this will host all our drawing calls. So we'll call canvas.drawRect, canvas.drawText, whatever. And then we have the draw commands. So this describes to the canvas what to draw. And lastly, we have the paint that we will use to draw with. So this describes to your canvas how to draw the thing that you want to draw on screen. So your paint can tell you the color, the typeface, and that kind of thing. Okay, so what can I actually draw onto a canvas? So there are many different things that you can draw on a canvas, but one probably very used or highly used function is to draw a bitmap, right? So a bitmap, for those that don't know, is just an image. So in this example, we've got the Toy Story image. And Canvas provides this function that we can say canvas.drawBitmap, provide it in the bitmap object that we want to render on screen. And then we can provide it a few other things that we'll have a look at now. The first thing, the null argument here, which I should have maybe given a better description, is basically you can send in null, but this is also you can like section off your bitmap. If you only wanted to draw a certain section of your bitmap on screen, you can use that argument to do it. And then the dest rect name of the variable there, that is basically describing where the destination of what the rectangle is that you're going to draw on screen. So you can describe the width and the height and the position of the thing that it's going to be rendered on screen. And then the last parameter is the paint, and we'll go a little bit more into detail about what that does soon. Okay, so it can be quite confusing to work with canvas.drawBitmap. You can see this example. I have clearly stretched the Toy Story image quite a bit, and this is because I set the destination rect of the image that I wanted to draw to the whole size of the screen. So I set the width and height and made it full screen. So it can be quite confusing, and it's easy to stretch things like you can see here. So I would suggest that you make sure your values that you're passing into these functions are correctly scaled to the correct aspect ratio, because the canvas doesn't know anything about the size of your bitmap or the aspect ratio that it needs to maintain. So one such way to deal with this is to normalize your canvas values, and we'll talk a little bit about that later on today as well. Okay, but the canvas doesn't just have drawBitmap as an API. There are many, many functions. So if you've gone and looked at what a canvas can do, you can do many different things. Like you can draw a rectangle, you can draw a circle, you can draw paths, you can draw text. There are so many different APIs. And I'm not going to go through all of them today because it would be the whole night. But basically, these are 2 others that I thought were pretty interesting. So in the example of the color dropper, we have drawn a circle for the outside circle. We've drawn a circle for the color of the circle. And then we've drawn a little tiny little rect in the middle. And basically those are the 2 calls, like draw rect, and you give it in the point that the rect needs to be drawn and the paint, and draw circle, which takes the x and y coordinates, the size of the circle, and also the paint or the color that you want the circle to be drawn with. So that's looking at the different kind of Canvas APIs that you can use. But feel free, go have a look at the documentation. There's a whole bunch more. These are really the sort of top ones that I use a lot. Okay, but let's talk a little bit about the paint object. So this is kind of my favorite graphics class, and people think I'm a bit weird that I have a favorite graphics class. But hopefully I'll show you why I think it's really cool, and there's so much you can do with it. But basically with a paint object, you can do so many different things, and because of that, it's really powerful. So you need to be aware of what you're doing with it. And it has also some of the coolest things that you can do with it too. Okay, so a paint, like kind of how you would think a paint in real life works, basically holds style and color information for drawing different things, like drawing your text, drawing paths, drawing bitmaps, all that kind of stuff is supplied with a paint object. So in this case, I'm creating just a paint object and then applying different properties to it. So applying the color of red and applying a paint style of a stroke. Okay, and then one important one is the anti-alias flag. So is anti-alias, and basically what that does is allows your drawing to render in a smooth way. Okay, so when you don't enable anti-alias, you might see very jagged edges of things when you're drawing it on screen. So you might see, like, if your bitmap is rotated, you might see it pixelated on the ends, or it might just not look as good as what you think it should look. So you need to enable anti-aliasing in order to smooth out the edges of the drawing that you're doing on the screen. Okay, but Paint can also hold a whole bunch of other different things, such as your typeface information, so fonts. If you wanted to set Comic Sans, for instance, you can do that with a Paint object, and it can also hold interesting things like shadow layer information. So you'll see here at the bottom we've set letter spacing, text size, typeface, and also the set shadow layer as well. We'll talk a little bit more about the set shadow layer in a bit and how interesting it is. But did you know Paint can also do other cool things, such as working with shaders? Okay, so in this example, the good old, oh no, it's not a video, oops. Okay, well, in this example, the good old color dropper view, we basically used a shader there to draw that zoomed in bitmap that's in the middle. I don't know if you can see, but basically where that point is, it zooms in a little bit on that bitmap where it is. And a shader is actually what did that, because we created a thing called a bitmap shader, and that takes a bitmap in, and you can scale your bitmap or translate it and stuff like that and get that cool zoomed in effect. So how do you do this? Sorry, having troubles holding two things. Okay, so to draw that cool little zoomed in bitmap that was on the color dropper, we create a bitmap shader. So the bitmap shader takes in that backing bitmap of the whole view, and we set like tile modes of the thing, and we set the shader on the paint. So you can see in dropper paint, we say shader equals bitmap shader, and then we do some things to that bitmap that we're going to display on screen. So we want to scale it up a little bit, and we want to translate it to the point that's going to be visible on screen. So we use a matrix to do that. I'll talk a little bit about matrices in a bit. But basically, a matrix allows us to like scale things and translate. So we can scale our bitmap at a certain point, and then we can set the matrix of the shader to that matrix that we've just created. And then to get that actual bitmap drawn on screen, we can then say draw a circle with the same point, X and Y, the size, and then this dropper paint will have this bitmap that is now zoomed in. And it does all that cool effect for us. Last look at what it does. Maybe not a good example, but yeah. Okay, so one tip I have for working with Canvas code on Android is to use KTX for cleaner code. So KTX is basically a set of common extension functions provided by the Android team at Google. And to include it in your project, That's probably not the latest version, but go have a look at what the latest version is, and you basically just include core KTX in your Gradle file, and then you'll get access to all these functions that I'm going to talk about now. So when you're working with Canvas, you can do something called rotating and translating of the actual canvas that you're drawing onto. So in this example, I'm translating my canvas to 200 and 300 pixels offset, and then I'm drawing a circle, okay? But the important part here is that I'm saving my canvas at a certain point, translating and then drawing, and then restoring back to the original point or the original config of that canvas, okay? And this allows us to do anything between those 2 points of save and restore will now be drawn at that translated point, okay? And you can see like this code is actually quite difficult to read because I don't know now, when I insert a line of code underneath draw circle, it's not immediately clear to me that that is going to be drawn on a translated canvas, right? But it will be because it's between the save and restore commands that a canvas has. So there are extension functions in KTX. One of them is called with translate, and basically they allow you to have blocks of code within the with translate block, okay? So now you can nicely see it's indented and it's within my braces. I now know that this draw circle command will be drawn on a translated canvas, and anything after that last bracket will be drawn on a non-translated canvas. So here is another example, just for more visual of how it works. Now this is also without KTX. So we have the first time we say save the canvas state, so save the current state of the canvas, then translate the canvas to 200, 300. Then at that translated point of the canvas, draw a circle. And then after you've drawn a circle at that translated point, rotate or save the canvas again, and then rotate the canvas, and then draw a rect on that translated and rotated canvas. Okay, and then we want to restore back to those certain checkpoints that our canvas state had. So you can see, like, immediately now, I have no idea what that draw rect, what the state of the canvas is at that point. It's really hard to see and read where it's going to be drawn, like what offset and what rotation. But if we use the KTX extension functions, you can see now I say first canvas translate. Everything inside that block is now going to be on the translated canvas. I draw the circle. I then rotate that translated canvas. And inside that, I draw a rect. And now we can easily see, okay, this draw circle command is only drawn on the translated canvas, but the draw rect command is drawn on the translated and rotated canvas. And this makes your code a lot cleaner to read and a lot easier to see where exactly your canvas is translated and what exactly is drawn at that point. Okay, so I mentioned matrices a bit earlier, and basically a matrix makes canvas operations really easy, well, not really easy, but easier to use, and helps you when you're working with like graphics stuff to calculate certain things. So the tip in this case is to use them because they're really cool and make life easier. So what is a matrix exactly, before I know like I should use them? A basic matrix in Android, an Android graphics canvas, or Android graphics matrix, is a 3x3 matrix that's used for transforming your canvas or coordinates of your canvas. So it can do things such as scaling, skewing, rotating, translating, or perspective drawing. So you can see the examples down here. So if you did linear algebra in university or have touched on it on the internet, matrix is basically the same thing from linear algebra, and now is when you actually get to use your linear algebra knowledge. Okay, so how do I use a matrix? So basically you just create a new matrix. You probably don't want to be doing that in your onDraw because it can be quite expensive. And then in your onDraw method, you just do things to your matrix. So in this case, I wanted to rotate my matrix, and I give it a degrees of 20 degrees. And then Canvas has, KTX has another extension, which is canvas.widthMatrix. And now everything within that block will be drawn with that rotated matrix in mind. So you can see the bitmap that we're drawing on screen is now rotated because it is using that matrix. But we can get into even more interesting stuff with matrices. So this is something that you can't do with the standard Canvas APIs, and you need to use a matrix to do this. And basically you can do perspective drawing. So you can see in this example, the Toy Story image is kind of like morphed a little bit or moved as if it sort of looks a little bit 3D. It's not 3D, it's just tilted and squashed a little bit. But basically a matrix has this method called set poly to poly, and that tells your any canvas calls that happen with that matrix to map certain points that are happening in your drawing, to map them to other points. Okay, so in this example, the source and destination, the source is the source set of points that we're going to draw on screen, and the destination, or the DST, is what we're going to map it to. And don't really worry about the other parameters. I've got a blog post on it that explains it if you really want to know. But basically here is the destination and source arrays. So it's a bit confusing because it's actually points that it's using, but it is, they're like in pairs. So the first two will be grouped together, second two will be grouped together, and that kind of thing. But here you can see the first point of 0, 0, or the top left point of our bitmap, will be mapped to the point 500 by 200. And that sort of carries on for every single point or pair within that matrix, within that array that you define. So that you can see now the bottom right point of the view, the height of it, or the Y, is going to be 200 extra than what it is when it is drawn on screen. And that gives the cool perspective drawing that we see there. Okay. So when you're working with Canvas and you're working with events on Android, like input events, like touch events and stuff like that, you might find yourself working between two different coordinate systems. So you'd be working with the touch events and how they happen on screen, and maybe you have your own internal definition of your representation of what you're drawing on screen. So maybe you're rendering something between, all your drawing code is happening between 0 and 100, and your view that's drawn on screen is actually like 1,000 pixels by 1,000 pixels, okay? So I'm going to talk a little bit about how you can work with between those two coordinate systems, excuse me. Okay, so working with sizes and points when you're dealing with Canvas and like drawing things on screen can be quite difficult. So in my example, I have a data class, or like my representation of what I'm drawing on screen is in the range of 0 to 100, just because that makes it easier for me to know and position stuff on screen. But my measured width and measured height of my view is actually 1,080 by 2,180. So it gets a little bit tricky to work between these two and like translate between the two. So my suggestion is to scale and translate your canvas early on in your rendering flow. So in this example here, I have a size object, and that size is the size of my like data class that I'm rendering on screen. So for instance, it could be my 0 to 100 size, so maybe it's 100 by 100. And then I have a method that fits center, basically fits this size inside the bigger canvas size. And that canvas size is like 1080 by 2180, okay? And this function just calculates exactly how to offset and the scale that we need to go between to get between these two different coordinate systems. And then what you do once you have those values is initially early on, just translate your canvas and scale your canvas to the size that you're working in and that you're comfortable with. And that'll make everything else from this point on, you can work with your coordinate system that you are working with. So 0 to 100 or whatever your logical system is. And this then makes sure that you don't have to times everything by a scale everywhere in your drawing code. So it makes it a lot easier to work with. Okay. And then let's talk quickly about mapping points between two coordinate systems. So say, for instance, you draw something on screen like this is our screen size, and then we have something that we're drawing like a square that we're drawing on screen, and then we have a user taps at that certain point on our screen. Now, when you're working with Android, you would typically get a touch event that is happening in between these coordinates here, so between this point and that size. So it's not between this size that we've got rendered on screen. So in order to know exactly what that position is within this coordinate system, so as if this was 0 and that was 1 or whatever, we want to know what this position is here, but not within the whole touch screen event. So to do that, to map between these two systems, we can take and use a matrix, take in our input points, apply all the transformations to that matrix. So to get this image to this way, we translated and we rotated the matrix. And then we can use a method called map points on that matrix. And that takes in the float array of the points, so the X and Y position, and then it just in place replaces the values, and now this point that we've got is translated and rotated around that same position that this square or image that we're drawing on screen is rotated around. So that map points function is actually really useful and makes working between coordinate systems a lot easier. Okay. Another tip that I have is to check that the Canvas APIs that you're working with are available across different API levels. So one such example of this not working really well is paint.setShadowLayer. So if you remember from a few slides ago, we spoke about adding a shadow to a text or a paint. And we were like, yay, we've got a shadow, right? There's a method called setShadowLayer, so it should render a shadow on screen. Well, it works with drawing text. Great, we can draw text and we can give it a shadow. That's awesome. But the things get a little bit weird when you start to draw bitmaps and enable hardware acceleration or disable hardware acceleration. And it also doesn't really work well at all with draw paths on the screen. So the setShadowLayer basically only works with drawing text on a screen. So here's an example of what it looks like. So I'm setting a shadow layer on a bitmap that I'm drawing on screen. And you can see the first example is on API version 26. And this is with hardware acceleration enabled on the device. And then this second example is API 28 with hardware acceleration and API 26 with software acceleration. And you can see it's not even really a shadow. It's like a duplicate of the bitmap, and it's a little bit blurred around the edges. So it's not really what I was expecting from what a shadow would normally look like for me. Okay, so learnings from this is test on all the API versions that you're working with to ensure that the functions that you're using work on all these different levels. And test with hardware acceleration on and hardware acceleration off. So let's talk a little bit about hardware acceleration and software acceleration. So when you create a canvas off screen, okay, so you're just manually yourself creating a canvas and you're giving it a bitmap to render onto, that canvas is always software rendered. So it doesn't have a view, or it's not visible to the user on screen, and therefore can't use the graphics card to actually render it on screen, or it's not rendered on screen, so it doesn't use the graphics card, so it is rendered in software. And then if you create an on-screen canvas, so you create a view and that has a visible thing to the user, you can then choose between if you want hardware acceleration on or software acceleration. So you can disable hardware acceleration, but you probably don't want to do this because it's faster to use hardware acceleration. But if you wanted to, maybe just for testing, you can, when you create your layer, you can just say layer type software on the type, and then you'll get a software rendered canvas. Okay, but there is also this great guide. I mean, it's not amazing, but at least it shows you, this is a list of all the things that don't work on Android canvases. So if you wanted to go to that link, I'll post the slides as well afterwards. But basically it shows the differences between when this canvas function was supported from. So you can see some of them were supported from 23 only, some from 17. Some are still not supported at all. So you can have a look at that. And it also shows when they are hardware accelerated or when they're not and stuff like that. So if something's not working and you don't know why, maybe go check out this link and it'll explain a little bit more about the things you're seeing. Okay, so main tip is to test your canvas code on different API levels. Cool. So when should you use, so I got this question on Twitter of when should you use a custom view versus a fragment versus just using the includes tag. And a custom view, this is my opinion, right? So this is not like, this is what I think when I go and make these things. It's not something from a documentation or something like that, but this is how I think of when I should create a certain thing. So for a custom view, I create one when my built-in components just don't cut it. So an edit text is just not what I need, or I need extra things on top of that. And also maybe when I want to encapsulate logic and expose just like more generic callbacks to the calling component or calling view. And I don't want other like users of my components to be aware of the details or know exactly what this thing is rendering. I don't really want them to know. Then I use a custom view and it's a little bit more wrapped up and they don't need to know the internals of it. A fragment is basically, I choose to use a fragment when it's like a whole logical component in my app that's mostly standalone and it doesn't need custom drawing. So if I need to draw custom stuff like a circle or rect or something, I'll go to a custom view. And I use generally like the built-in components for this plus custom views with inside a fragment. And a fragment, I kind of, when I make one, is when I don't really need callbacks to other parts of that view that you have on screen, because it gets a little bit messy and you have like to pass view models around or like cast contexts and stuff, which is a little bit horrible. Whereas custom views, you can like quite nicely provide callbacks to the calling component. And then an include tag is basically just a bunch of views that you want to include in different other layouts. And it's literally just a bunch of them grouped in a file. And this I use when like the other layout that needs it needs to know each individual component that's going to be put inside that layout. So maybe it needs to know that there's an app bar, or it needs to know that there's a back button or something like that, and do custom things with it. I don't use an include when I need to do things like custom logic around touches and drawing and stuff like that, because that you want to wrap up in a custom view. And this obviously is when you want to manually handle each of the component logic yourself. Okay, anyone heard of Jetpack Compose? Few people. Okay, so basically, you might be thinking, the ones that have heard of Jetpack Compose, and we'll get into what it is, but you might be thinking that all of this might go away, all of Canvas, all the stuff that you've just taught me might not be relevant now with the new thing of Jetpack Compose. So Jetpack Compose is a new way of writing UI on Android, and it's basically what they call a declarative UI toolkit for Android. And this has been inspired by many other different frameworks like React or Flutter or Vue, and it is very important to note, it is not in production, it's not ready to be shipped with your production apps. It's very, very early stages, it's pre-alpha even, there's not even a Gradle dependency that you can include, so don't use it in production. And it's unbundled from the platform, so this should mean less bugs because they're not shipped with the OS update, they're shipped with your app. So basically Jetpack Compose is very different thinking to what we normally used to when creating views on Android. And you have this, this is directly from the docs, so I didn't write this myself, but you have this @composable annotation that you have on your functions, okay? And this is basically creating a text view. Okay, so you're saying this text view is called greeting, and we're going to pass in a name, and we're rendering text on screen. It's a little bit different from just creating a text view in XML and having your activity inflated. You create it all in code yourself. So you might be thinking, oh, well, now I don't need to know anything about Canvas because Jetpack Compose is coming and it's all going to replace everything you've just taught us about Canvas. Well, turns out you still need to know Canvas, and it's still the same sort of APIs and things under the hood, as this is one example that I also took from the example docs. And this is basically a function that is drawing a rectangle on screen. So you can see very similar concepts here, like a paint class, same as what we've been dealing with, and that we set a color on. And then there's a draw command, and that we have a canvas. See, there's the canvas. And we are drawing a rect onto the canvas. It's very similar to what we've seen. And we have a paint that passes into that. So don't despair. If you've learned about Canvas, or this past 40 minutes wasn't a waste, hopefully, it will be applicable when we do use Jetpack Compose at some point. So some final thoughts around working with a canvas on Android. The first tip I said is to normalize your canvas coordinate system, so making it easier for you to work with your canvas that you're drawing on screen, so you don't have to times values by scales and translate and stuff like that. And then use the matrix for easier transformations, so without having to do a lot of geometry and stuff yourself, make use of the matrix, apply your rotation, your scale, and that kind of thing. And then double check that the canvas features that you're using are available for all the APIs that you're working with. So we saw the shadow layer didn't really work so well with certain versions. And then also use KTX. So KTX makes our canvas code a lot easier to read. And lastly, canvas concepts aren't disappearing anytime soon. So this canvas stuff is very applicable to other platforms as well, and in the future, Jetpack Compose too. So thank you very much. Any questions? Yes?
On your example code, I saw Android X. What is the difference between Android and Android X?
Okay, good question. So Android X is basically a bunch of extension functions, or not extension functions. Android X is like, it used to be called the support library. Do you remember that? I don't know if you've worked with that. But the support library and Jetpack and Android X, very similar names, very similar function. But basically that is stuff that's built on top of Android that is not part of the platform itself. So it's not part of the SDK that ships with a device. So it is a library that you include inside your app, and then you ship that with your app. But it's provided by Google to make your life a bit easier when dealing with certain things, like, for instance, Recycler View is part of Android X, and these extension functions as well are also part of Android X. But Android X, if you want to Google it, is also code for Android Jetpack or Android Support Library. They've renamed it a few times, but yeah. Cool. Hi, yeah.
So my question was that Canvas, the API, can you maybe create games with it, or it just only works with pictures?
Yeah, that's a good question. You can create games with it. It's probably not the right platform for it exactly. I would maybe use something like Unity, or other game platforms, like, what are other ones? Unreal Engine. Yeah, but basically you can do animations and small things with a canvas, but I don't know, I wouldn't go so far as to create a game with a canvas, because you're going to want a lot more advanced things within it, and you probably won't get that with a canvas. Simple games. Cool. Yeah.
Is there any APIs to like UI test these things? How do you UI test Canvas stuff?
Yes, there is kind of. I mean, you can screenshot test. Okay. So there's a thing from Facebook called screenshot test that you inflate your view. So there is, you can just inflate normal views in tests. You can inflate your view and like take a screenshot and compare it to a previous screenshot. That's one option. But you can also write like your own custom, they call them shadows, with RoboElectric. Okay, so RoboElectric allows you to like mock out Android things, and you can inflate your view in there and then create a custom shadow. I'm not going to go too much into that because it's a little bit hairy, but you can do that and then assert that certain things are set with your shadow in mind and that kind of thing. But you won't get the exact, like, the only way to know that it's rendered properly is to take like a screenshot. Cool. Thank you.
Thank you so much.